Okay, in this lesson we are going to continue working with independent and dependent variables, and we're going to look at the relationship between them. We're going to look at the mathematical relationship between them, which usually you see in patterns that you can see in tables and graphs. So that's what you're going to be able to do today, is identify those patterns. So let's go ahead and check out the answers to the do now. So this warm-up is all about understanding that we're dealing with two different quantities, and when you change one, the independent variable, it causes a change in the other, the dependent variable. So that's what I was trying to get at in this table, identifying an independent variable and a dependent variable, and then talking about what happens when you change this. How is that going to affect the dependent variable? And again, mathematically, you're going to see some patterns in how the dependent variable is impacted. All right, again, for this one, the money that she earns is dependent on how far she walks. Again, the more she walks, that change means that you increase the money that she raises. All right, let's take a quick look at the homework answers. All right, make sure you're good with these answers, and keep in mind that you could make up some different sentences with these combination of variables and letters. So this is not the only answer. There are many answers that will work here. All right, let's get to the lesson. So please turn to the next page. There are several ways to look at the relationship between an independent variable and the dependent variable. We're going to look at two in this problem. You can look at the relationship in a table form, and that's what you're seeing here. You can also look at it in a graph form as well. So what I'd like you to do is take a look at the numbers in this situation, Rocky's weekly rental rates, and take a look at Adrian's weekly rental rates. And just take a look at the numbers and look at how they're increasing, and see if you can figure out which rental place is the better deal. So I'd like you to pause the video, again, take a look at these numbers, and then I want you to answer the question below and then come back and we'll see how you did. All right, so I think Rocky is the better deal, because even though he starts off a little more expensive, so you can see for 10 bikes, Adrian is under 400, but 10 he's 535. However, once you rent more and more bikes, he ends up becoming less expensive. So even if you look at 50 for Adrian, that's almost $1,600, and he's only $1,200. So I think Rocky is better. But you could make the argument that Adrian's better, especially for smaller numbers of bikes. He could be the cheaper one. So the point is, there's a relationship between the number of bikes and the rental fee. That fee is dependent on the number of bikes that are rented. But they have different relationships depending on the bike company. All right, go ahead and turn to the next page, and we'll take a look at some more examples. All right, so we talked about seeing patterns in tables that represent independent and dependent variables. So your job for these problems is to figure out that pattern and then use that pattern to fill in the rest of the table. So let me just give you a little bit of a hint. You should look at how this number is increasing, or you can look at the relationship between the x and the y value. Can you multiply something to get it? Can you add something to get it? So you should be thinking of addition or subtraction options, or addition or multiplication or division options. There could be lots of ways to see the patterns here. So I'm going to let you try to see it on your own. So go ahead and pause the video and fill these out. The last one's pretty tricky, so we'll see how you do. All right, so here are the answers. And the first one wasn't too bad. I think you can see that you're adding 5 each time to get to the right answer. And the equation then is y is equal to x plus 5. Every time we add 5 to x. So we have a nice equation, x plus 5. In this problem, again, I'm looking to see what can I do to get from 1 to 3. Well, adding doesn't give me the same amount each time, but I can see I can multiply by 3 each x value to get the y value. And I can fill out the table accordingly. So my equation is y equals 3 times x, because I'm multiplying this by 3 each time. In this one, I'm dividing by 2. So 2 divided by 2 is 1, 3 divided by 2 is 1.5, 5 divided by 2 is 2.5. This one I need to have the bigger number, so 10 divided by 2 is 5. Just like I had 120 divided by 2 is 60. And the formula, their equation, is y equals x divided by 2, like a fraction. Now the last one was pretty tricky. So you may have seen some patterns to fill this in possibly, but what you're actually doing is 2 operations. This is a 2-step equation. So as it turns out, if you multiply this by 3 and then add 1, you'll get to the y. So 2 times 3 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. 4 times 3 is 12, plus 1 is 13. 5 times 3 is 15, plus 1 is 16. So that gives us this equation here. If you have trouble getting that, not a problem. That's a pretty tricky one. All right, let's turn to the next page. All right, in this problem, I would like you to fill out this table based on the problem situation where he is saving $100 every month, and then I want you to identify the independent and dependent variables. So go ahead and pause the video, finish this problem, then come back and check your answers. All right, check out these answers. So you can see that for every month he adds another $100 to savings. So after 2 months he has 200, 3 months he has 300, 4 months he has 400, and so on. So the amount of savings depends on the number of months that he saves, right? We're changing this number, and then we're watching how this number changes. So that makes month the independent variable. That's kind of what happens first. And then amount in the savings account is the dependent variable. So we're waiting to hear how many months, and then whatever that is, that will tell us how much savings that he has. All right, that's a table form. Now in the next slide, we're going to look at this same data in a graph form. So go ahead and turn to that page, please. So what's the relationship between the x and the y? And hopefully you can see that I am getting from x to y by multiplying by 100. 2 times 100 is 200, 3 times 100 is 300, 4 times 100 is 400, and so on. So here's the same data in graph form, and you can see at 1 month it's 100, at 2 months it's 200, at 3 months it's 300. And we need an equation for this. But let's go back to the table for a second. So my equation becomes, I need my pen tool, y equals 100x. And we can see that as more months pass, the amount of money in Carlos' savings account increases. I don't think there's any doubt about that. We can also say that as x increases, y increases. Because x stands for months, and y stands for money. All right, go ahead and turn to the next page for some more practice. I'm going to let you try this one completely on your own, so go ahead and pause the video and complete the table, complete the graph, and answer the questions about independent and dependent variables. So go ahead and pause and then come back and see how you did. All right, check out these answers. So let's see. So for one ticket, there's an original cost of $4, plus $2 for the ticket gives me a total of $6. For 2 tickets, again, we have a starting cost of $4. $2 for each ticket is another $4, that gives me $8. And we have 4 plus 3 times 2 is 10. Another 4 plus 4 times 2 is 12. And then 5 is 4 plus 5 times 2 is 14. And then if I label each one of these as 1, 2, 3, 4, 5, here is the graph. So the independent variable is the number of tickets sold, right? That's the amount that we don't know yet that we're going to change. And depending on how many tickets sold will determine what my total cost is. All right, so I buy a number of tickets, and that lets me know what the cost is. This comes first, then the cost. All right, so you can see that as number of tickets increases by 1, the total cost increases by $2, which is kind of interesting. And then this equation, we've done this before. This is a translation, right? We know that we have $4 just to start off with, and then each ticket costs 2. That keyword of each implies multiplication. So we start off with 4, and then we add to that $2 for each ticket. So we can plug in any number of tickets to find out the total cost Y. All right, so go ahead and take a look at the homework if you finish this early, and let me know if you have any questions.